Hello everyone. My name is Gadi Sandeep, currently pursuing a Bachelor of Technology in Electronics and Communication Engineering at Srinath Institute of Science and Technology. I have recently completed my IoT internship at Emertxe company, where I have gained an hands-on experience in embedded systems and IoT applications. So, in this presentation, I will be explaining my internship journey, what I have learned, and my final project about smart home automation using Arduino and Blynk IoT cloud. So, let's go to into the presentation. So, basically, what is the internship overview and main objective of the internship? Uh, So, main objectively, they will focus us mainly on embedded and IoT fundamentals with an programming skills like C, C++, and Arduino-based simulators. And coming to an practical exposure, they will directly work with an sensors, actuators, and IoT platforms to in real-world implementation. So we can have an experience with working with sensors, actuators, like sensors like LM35, LDR, ultrasonic, and various kinds of sensors and actuators, motors, different kinds of motors, servo motors. Like coming to the learning methodology, they basically use the learning for real-time simulation, fixing simulator for safe and iterative development and testing. So about the company, about the Emertxe company is an leading training institute in Bangalore specializing in embedded systems and IoT. The training emphasizes practically learning and real-time projects, helping students gain industry-ready skills. So I have learned both recorded session and project-based practice. So coming to it is an majorly it training institute and it has a project-driven learnings. Simulators fixing lab is used for the to develop and projects. And coming to the expert mentorship, the mentors are available to solve the problems often students faced during an online internship. And coming to the curriculum, they follow a strict curriculum. Based on the curriculum, they will go ahead and complete the internship on time with an experienced knowledge and skills. So during my internship, what I have learned. So basically, the basic to learn any to develop a project on hardware like embedded systems, we have to know the basic foundation of C and C++. So in the course C programming, I have learned the basics things. They have teach the basic things like what is variable, data types, number system, operators. Coming to a variable is a name given to a particular memory location. And data type is the type of a data to be stored in a particular memory location. And coming to the number system, they have teach the different kinds of number system like binary, octal, hexadecimal, decimal. And coming to the operators, like usually available operators, they have these like arithmetic operators, bitwise operator, logical operators, relation operators, assignment operators. And coming to the arrays, functions, and modulatory. So we basically know arrays is a collection of an element with same data type. And they discuss about the 1D array and 2D array, how we can use the array in our project. And functions, they describe the function set of instruction including in function and how the function will help in debugging, code reusability, modularity. And coming to the basic main important topic in the C language is pointers, where an C program is not an low level language and a high level language. It is a medium level language since it has a pointer concept. Pointers is nothing but an it stores the address of an variable. So it directly dealing with an memory. So the C language isn't directly dealing with the hardware equipment, so it is known as a medium level language. And C language is used to deal with the hardware equipments. So, and they have teach the memory management, like different memory, how and memory divided, like user space and kernel space. In user space, there are different types of memory, like data segment, text segment, stack segment, heap segment. These kind of various segments, they have teach memory segments. And coming to the storage classes, they have teach the storage classes, different kinds of storage classes available in C language, like auto, register, stack, external, local variables, global variables. And coming to the preprocessor directives, they have teased how to include an library function, hash include function, different kinds of preprocessor directives, how to create an library function. They have teased various kinds of libraries, how to create. And coming to the C++, it is a superset of an C language, and they have teased in the C++ like what is class, object, constructor. Coming to the classes is an user-defined data type. It can have the data members and members of the variable. So class is an blueprint of an object. Class does not allocate an memory until and unless an object is created to a particular class. So coming to an object is an instance of a class. It's an entity, real world entity like an. And for to access the data members and members of the classes, we need an object to an class. Coming to the constructors, constructors is a special method used in the OOPS concept. It has the same name of the class name and does not have any return type of the constructor. The main purpose of the constructor is used in the OOPS concept is used to initialize the variables. So coming to the inheritance. So different types of inheritance are available. So first basically inheritance. What is inheritance? A class acquiring the properties of another class is known as inheritance. The classes are available two type base class and parent class. So types of inheritance they have is like single inheritance, multiple level inheritance, multiple inheritance, hybrid inheritance. And coming to the poly means many, morphism means many ways, many forms. So a method is used for many purposes is known as a polymorphism. We can use a method for many functions like based on the number of arguments and type of the arguments. And coming to the encapsulation is nothing but a wrapping of a data into a single unity. A class is an example of an encapsulation. Coming to the abstraction is then showing the necessary details and hiding the unnecessary details is an abstraction. We can basically use this abstraction for in the banking system or many things we can use in abstractions. And we have learned the foundation of an embedded system and how the what is an embedded system, how we can work with an embedded system, what is an IoT. So let's go to the next slide, what I've learned. So for the hands-on IoT, that is the embedded system. First of all, what is an embedded system? We basically know an embedded system is a combination of an hardware and a software used for a specific task. So we can see the embedded system examples in our daily life, like a phone, laptop, AC, microwave, washing machine. These are the designed by using an embedded systems. So and what is an IoT? They teach us what is a basic definition of an IoT. So the IoT is nothing but an physical object or entity which have an embedded property in it are connected to a network called an internet or any network used for access or exchange the information. So basically a definition of an IoT is connecting a different kinds of objects or devices to an internet to access or exchange the information. And they'll teach us the embedded programming, embedded C language, and a microcontroller fundamentals. And they teach the sensor interfacing, like l- the real time. And I have learned the basic sensors which are used in our project, like LM35 and LER sensor. Uh, LM35 is a temperature sensor for measuring the temperature, room temperature, and LDR I have used for the lights, light dependent resistor. And coming to the LED used for light emitting diode is used for to showcase that an turning on and turning off an bulb in an home equipment. And coming to the PWM, we learned about the PWM pulse width modulation, how the pulse width modulation will help to control the actuators. The basic term pulse width modulation is used in an Arduino for increasing and decreasing the duty cycle. So there basically PWM pins are available in an Arduino board where we can connect those pins for then output devices to control or speed up the devices. Like basically, these PWM pins are used for the actuators, like motors, to increase the speed of a motor rotations, to increase the rotation per minute. Basically, this PWM is used with a function called analog write function, and they teach us, and basically they teach about the cloud integration. Basically, we use the Blynk IoT integration for real-time data transmission between the Arduino board and app application, Blynk IoT application. All learning conducted using Pixim simulator for practical simulation and testing purpose. And coming to the basically my project is an home automation system. It is an basic project, basic design and implemented an intelligent home automation system using it can be controlled using a remotely using a smartphone called an application Blink IoT. The basic aim of this project is used to control the home appliances like heater, cooler, lights, and a water tank using an application called Blink, which is available in our mobile. And it will show, and the advantages of this project is it will show the real-time temperature, volume of the water on the application. And the project components and tools I have used in the projects are like microcontroller. Basic, the brain of the system is a microcontroller. The microcontroller I have choose the Arduino Uno because it is an easy way to learn any microcontroller. So Arduino Uno. So basic stuff of an Arduino Uno is it has an microprocessor of an 8 mega 3288P, and it has a 14 digital pins, 6 analog pins, and it has available a PWM pins, and it has a 10-bit resolution. It has a 10-bit resolution. The microcontroller, it is used for any Arduino Uno used to communicate between the sensors and actuators. It acts as a mediator between sensors and output devices, input device and output devices. So basically, for the connectivity through the Blink IoT, we need an internet. So Arduino Uno doesn't has direct access to connect to internet. It doesn't has any Wi-Fi module. So to connect to the internet, I have used an Ethernet shield. So this Ethernet shield will provide a network communication between Blink Cloud and Arduino Uno. So I have used an Ethernet shield. Coming to the actuators, basically, the actuators I have used in the projects called heater, cooler, and water tank for the inlet and output. Inlet and outlet valves are available in the water tank, and LED for showing the turning on and turning off the any bulb in an house. Coming to the sensors, the basic two sensors I have used in the project like LM35A and LDR sensor. So basically, the LDR sensor is a light dependent resistor, and it has an resistor when the sunlight falls on the LDR sensor, it will increase the voltage. Coming to the LM35, it has a thermistor resistor. Based on thermistor resistor, it will display the temperature. And the Blink IoT platform I have used for remote monitoring and control interface for connecting to show the real-time data. So I have used the Blink IoT for development. I have used a Pixim simulator for prototyping and testing. So basic system architecture and features of the project is used for basically the LDR sensor is used the LDR sensor is used for controlling the gardening light. Based on the sunlight levels, it will directly turn on and turn off. At the daytime, the sun is available, so the lights will be turned off. At the nighttime, the sunlight is not available, so at the nighttime, the LEDs will be turned on. So I have used the temperature sensor LM35 sensor to control the heater and cooler based on the temperature level, and to display the LM35 temperature on Blink IoT app. As the temperature increases above 35 degrees, it will automatically turn on the heater. And system control, I have used an water tank for manages the inlet and outlet valves using a serial communication. We can manage the water tank. We can control the water tank inlet valve and outlet valve using the serial communication. And to display a real-time data, I have used an Blink app for for displaying a volume of the water temperature. So I will showcase how the Blynk app look the interface and dashboard. Like I have used the CLCD to show the all the readings of in temperature, volume, and which equipment is on, which equipment is turned on. So to display all the equipments, I have used a CLCD, liquid crystal display. So coming to the project outcome, I will once go through my project. Wait for a minute.
So this is the actual representation of my project home automation system, where I have used the CLCD display for displaying the heater, temperature, all the values of a project, and I have used the I2C to connect the LCD display. I2C is the integrated circuit to connect the I2C to the LCD, and I have used the LDR sensor. Based on the light intensity, it will turn on and turn off the LEDs based on the sunlight levels. And I have used the temperature system where it contains the heater, cooler, and inbuilt temperature. It will measure the temperature. Based on the temperature, it will send the readings to the Blynk IoT and CLCD display. And I have used the Ethernet shield to connect the Arduino Uno to the cloud for real-time data access through internet. So I have used the serial tank uh, to measure the water level, to turn on and turn off the, and to turn on, to connect the serial tank to an local bridge to Arduino Uno and serial tank. We have to use a local bridge. So I am creating the local bridge through the first port name and port 2. Create non-permanent device. Okay, then it will create an local bridge to connect the Arduino Uno and serial tank. So let's connect the Arduino Uno and serial tank. File, configure, com1, save. To pass the information from Arduino Uno to serial tank, we need a mechanism called SPI, serial peripheral interface. So serial tank is connect. When I click on the connect button serial tank, the automatically the water will flows in the serial tank. I have written the code in such a way that if the volume of the water is less than 2000, it will flows, what inlet value will be turned on, and the water will be flowed on the inlet in the water tank. So let's wait. The water will flow automatically. Let's see that. Wait for it's passing the information. See, the inlet valve is turned on and the water is filling on the tank. The water is filling. We can see that the water is filling in the tank. The maximum capacity of the tank is water tank is 3000. So let's wait. It will filling. We can it can shows the volume in the Blynk IoT. So I have using a power mirror to cache my phone to the laptop. Let's wait to showcase my phone screen. Blynk IoT template. I have created an home automation template in the Blynk IoT where we can see our home automation project in tab on in different. And the widgets I have created heater, cooler, temperature gauge, inlet valve, outlet, and volume gauge. We can see the real time volume. We can see same volume 2750 inlet valve widgets, outlet valve widgets I have created. And let's test once how it will work. So when I actually turn on and turn off, it will flow. See, when I turn outlet valve, the outlet valve is on, the water is flowing down from the serial tank, and the temperature is showing on the volume gauge in the Blynk IoT. So I have written the code such a way that when the volume decreases below the 2000 liter, the automatically the net valve will be on and the water will fills on the tank, water tank. So it is filling automatically. The water tank is not filling. We can turn off by manually in net valve. We can off and turn on. So it is filled the maximum capacity 3000. We can see on the Blynk IoT. When we turn on the outlet valve, the outlet valve will be on and the water will be flows down. Water will be decreased. We can observe in the serial tank and Blynk IoT app. same volume it will be shows. And we can look after the another side of the project like heater, cooler, and temperature, how it works, like test them. So I have used an LDR sensor for gardening lights. LDR sensor, when I based on the sunlight levels, it will turn on and turn off. At the night time, the sunlight level is too low, the LED will be on. At the daytime, the sunlight is high, so the LED will be turned on off. Based on the resistance value, the LED will be decreased and turned off and turned on based on the sunlight levels. And it will shows the display when I turn on the cooler. We can see the notification cooler on in the CLCD, and the cooler is turning on in the temperature measurement system. And when I turn on the heater, the temperature on the CLCD indicates that heater is on and temperature is increasing 27 20. And we can see the temperature gauge on Blynk IoT, the temperature is increasing. And I have created an I have wrote an code such a way that when the temperature raises to 35 degrees, the automatically the heater will be turned off. Let's see it will turn off or not. See, it automatically turned off when it reaches to the 35.19. So when we turn on the cooler, the cooler will be on and it will indicate on the LCD. Cooler is on and it is rotating the cooler. We can see on the temperature gauge on Blynk IoT that temperature is decreasing due to the cooler is on. And this is the actual presentation of my project where I have used for the home automation system. Where I used the Pixim Lab for design this prototype of a home automation system where I integrated the Arduino Uno and spare parts to a cloud of a Blynk IoT. This is the representation of the project. Coming to the key outcomes and skills developed, I have developed my proficiency in programming like embedded C and C programming, and work on the real-time system and IoT applications. And I have worked on the system design, complete an IoT architecture, sensors and actuator working on the and cloud connectivity, serial communication protocol implementation, cloud-based control Blynk platform, how to connect the Arduino Uno to the cloud to the Blynk IoT I have learned, and debugging and testing, advanced troubleshoot techniques I have used using Pixim Lab, complex problems to solve during the internship, and problem solving skills I have improved. And I didn't show the or what I have actually implemented a code during the project. This is the code I have dumped into the Arduino Uno. I have written the code for the home automation system. This is the actual code for all the output devices and input devices. I have written the code in a software called Arduino IDE, Integrated Development Environment. So let's go to the last slide of an PPT, internship outcomes and reflections, where I have increased my technical skills, hardware expertise, and sensor interfacing protocols like SPA protocols, connectivity, and Ethernet Shield, and a IoT platform mastery and professional growth. I have increased my problem solving, communication skills, and thank you for listening my presentation. It was a nice to present my internship to you. Thank you a lot. Thanks a lot to listen my presentation.